Welcome to Tech with Kaushik. This is part 1 of our complete practice question series for the SAA-C03 AWS Certified Solutions Architect Associate exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 1. Question number 1. A ticketing platform runs its web tier on Amazon EC2 instances in an auto-scaling group. Normal demand must always be served, but promotional events create additional workloads that can tolerate instance interruption. The finance team wants the lowest practical compute cost and will not accept any term commitment. Which EC2 purchasing strategy should a solutions architect recommend? Option A. Run the entire auto-scaling group on dedicated instances. Option B. Use on-demand instances for the baseline and reserved instances for all additional capacity. Option C. Run all instances as on-demand instances. Option D. Maintain an on-demand baseline and use spot instances for interruption-tolerant burst capacity. The correct answer is D. Maintain an on-demand baseline and use spot instances for interruption-tolerant burst capacity. Here's why. The on-demand baseline provides dependable capacity without a contract, while spot instances reduce the cost of flexible capacity that can be interrupted. Both options can be combined in an EC2 auto-scaling group without a long-term commitment. Why are the other options not correct? A. Dedicated instances add isolation expense that the workload does not require. B. Reserved instances introduce a 1-year or 3-year commitment, which violates the stated constraint. C. An all-on-demand fleet remains flexible but does not capture the substantial discount available from spot capacity. Exam tip. For elastic workloads with interruptible burst demand and no commitment, combine an on-demand baseline with spot instances. Question number 2. An online learning provider is launching a mobile video service for millions of customers worldwide. Course videos must remain private, and each authenticated learner should receive temporary access to the videos after signing in. Which architecture best meets these requirements? Option A. Require every mobile device to connect through AWS Client VPN before streaming a video. Option B. Deliver the videos through Amazon CloudFront and issue signed URLs to authorized learners. Option C. Place the videos in a public Amazon S3 bucket and use AWS KMS keys as the viewer access mechanism. Option D. Establish site-to-site VPN connections from user devices to the AWS environment. The correct answer is B. Deliver the videos through Amazon CloudFront and issue signed URLs to authorized learners. Here's why. CloudFront provides globally scalable content delivery, and signed URLs grant time-limited access to private objects only after the application authorizes the learner. Why are the other options not correct? A. Client VPN is designed for private network access and is not an efficient distribution model for millions of consumer devices. C. A public S3 bucket exposes the content, and KMS encryption does not replace viewer authorization. D. Site-to-site VPN connects networks rather than individual mobile users and does not provide internet-scale media delivery. Exam tip. Use CloudFront signed URLs or signed cookies when authenticated users need controlled access to private content. Question number 3. A live esports platform accepts UDP traffic from players and runs game endpoints in 6 AWS regions. The platform must reduce internet path variability, packet loss, and latency for players while automatically directing traffic to healthy regional endpoints. Which solution should the company implement? Option A. Create an Amazon CloudFront distribution and configure UDP origins in every region. Option B. Peer a transit gateway in each region with all other regional transit gateways. Option C. Create an AWS Global Accelerator with UDP listeners and endpoint groups for the regional game endpoints. Option D. Build a full mesh of inter-region VPC peering connections for the game VPCs. The correct answer is C. Create an AWS Global Accelerator with UDP listeners and endpoint groups for the regional game endpoints. Here's why. AWS Global Accelerator supports UDP and brings player traffic onto the AWS Global Network at a nearby edge location. Its endpoint groups and health checks route traffic to healthy regional endpoints over optimized network paths. Why are the other options not correct? A. CloudFront is an HTTP and HTTPS content delivery service and does not provide UDP listeners. B. Transit Gateway Peering connects private networks, but does not optimize the public path from players to the application. D. A VPC peering mesh is operationally complex and does not accelerate end-user internet traffic. Exam tip. Choose Global Accelerator for global TCP or UDP applications. Choose CloudFront for cacheable HTTP or HTTPS content. Question number 4. A serverless order API uses Amazon API Gateway, AWS Lambda, and an Amazon RDS for MySQL database. During sudden traffic bursts, many concurrent Lambda invocations open database connections and cause connection timeout errors. The company wants to reduce failures with minimal application changes. What should a solutions architect recommend? Option A. Increase the RDS-DB instance class so that the database can accept more connections. Option B. Replace the relational database with an Amazon DynamoDB table in on-demand mode. Option C. Place Amazon RDS proxy between the Lambda functions and the RDS database. Option D. Reduce the Lambda reserved concurrency to keep database connections below the current limit. The correct answer is C. Place Amazon RDS proxy between the Lambda functions and the RDS database. Here's why. RDS proxy pools and reuses database connections for concurrent Lambda invocations. The application can use the proxy endpoint with limited code or configuration change, reducing connection churn and exhaustion. Why are the other options not correct? A. A larger DB instance costs more and does not address rapid creation of short-lived connections as directly. B. Moving to DynamoDB requires a new data model and significant application changes. D. Reducing concurrency can limit errors, but it also throttles application throughput instead of efficiently managing connections. Exam tip. Use RDS proxy when bursty serverless workloads create too many short-lived connections to a relational database. Question number 5. A logistics application written in Java exchanges work items through Amazon SQS. Some payloads are now as large as 40 megabytes, which exceeds the native SQS message size limit. The company wants to retain the existing queue-based design and make the fewest code changes. Which solution should the company implement? Option A. Store each large payload in Amazon S3 and develop custom producer and consumer logic to exchange pre-signed object URLs. Option B. Use the Amazon SQS extended client library for Java so that large payloads are stored in Amazon S3 and SQS messages contain references. Option C. Request a quota increase that raises the Amazon SQS message size limit to 40 megabytes. Option D. Replace Amazon SQS with Amazon EventBridge and publish each 40 megabytes payload as an event. The correct answer is B. Use the Amazon SQS extended client library for Java so that large payloads are stored in Amazon S3 and SQS messages contain references. Here's why. The SQS extended client library for Java transparently stores oversized message bodies in Amazon S3 and places a reference in the queue. This preserves the SQS workflow and supports a 40 megabytes payload with minimal application modification. Why are the other options not correct? A. A custom S3 pointer implementation can work, but requires more code than the supported extended client library. C. The native SQS message size limit cannot be increased to tens of megabytes. D. EventBridge has event size limits and is not a drop-in replacement for this queue consumer pattern. Exam tip. For SQS payloads above the native limit, use the SQS extended client library with Amazon S3. Question number 6. A financial analytics company runs a capacity-intensive EC2 batch workload every week. The start time is fixed, but the amount of capacity required varies from week to week. Capacity must be available 30 minutes before processing begins. The operations team does not want to calculate instance counts or maintain custom scaling code. Which solution provides the least operational overhead? Option A. Configure scheduled scaling with fixed minimum, maximum, and desired capacities for each weekly run. Option B. Configure predictive scaling for the auto-scaling group and set a 30-minute scheduling buffer before forecast demand. Option C. Configure a target tracking policy that begins scaling when average CPU utilization reaches 60%. Option D. Use Amazon Event Bridge to invoke a Lambda function that changes desired capacity when CPU utilization reaches 60%. The correct answer is B. Configure predictive scaling for the auto-scaling group and set a 30-minute scheduling buffer before forecast demand. Here's why. Predictive scaling learns the recurring demand pattern, forecasts the required capacity, and can pre-launch instances using a scheduling buffer. The company avoids manually estimating desired capacity for each run. Why are the other options not correct? A. Scheduled scaling requires the team to determine fixed capacity values even though weekly demand varies. C. Target tracking reacts after utilization rises and does not ensure instances are ready 30 minutes before the workload starts. D. A custom event bridge and Lambda mechanism reacts to load and creates additional code and operational responsibility. Exam tip. Use predictive scaling for recurring but variable demand. Use scheduled scaling when the required capacity is already known. Question number 7. A research organization wants to retire an on-premises NAS appliance that provides SMB and NFS shares. Frequently used files should remain available through familiar file share paths, while inactive data must be stored as Amazon S3 objects and transitioned by S3 lifecycle rules. Which AWS storage gateway type meets these requirements? Option A. Provision a tape gateway. Option B. Provision an Amazon S3 file gateway. Option C. Provision a volume gateway. Option D. Provision an Amazon FSx file gateway. The correct answer is B. Provision an Amazon S3 file gateway. Here's why. Amazon S3 file gateway exposes SMB and NFS file shares to local clients while storing the files as objects in Amazon S3. Because the data resides in S3, lifecycle transitions can be applied without changing the user's file access method. Why are the other options not correct? A. Tape gateway emulates a virtual tape library for backup and archive software. C. Volume gateway presents ISCSI block volumes rather than SMB and NFS file shares. D. FSx file gateway provides cached access to Amazon FSx for Windows file server rather than direct object storage in Amazon S3. Exam tip. Choose Amazon S3 file gateway when on-premises users need SMB or NFS access backed directly by S3. Question number 8. A media processing fleet runs on several Amazon EC2 instance sizes within one instance family. The company will commit to a 3-year level of compute usage, but an application redesign in 6 months might require different instance families, sizes, operating systems, or AWS regions. Which pricing option provides the greatest savings while preserving the required flexibility? Option A. Purchase standard reserved instances. Option B. Purchase an EC2 instance savings plan. Option C. Purchase a compute savings plan. Option D. Purchase zonal reserved instances. The correct answer is C. Purchase a compute savings plan. Here's why. A compute savings plan provides commitment-based discounts while allowing usage to move across EC2 instance families, sizes, regions, operating systems, tenancies, and supported serverless compute services. Why are the other options not correct? A. Standard reserved instances do not provide the broad cross-family and cross-region flexibility required by the redesign. B. An EC2 instance savings plan is constrained to an instance family in a specific region. D. A zonal reserved instance is tied to a particular availability zone and instance configuration. Exam tip. Choose compute savings plans when the compute family, size, region, operating system, or service might change. Question number 9. A fleet of industrial sensors writes to an Amazon DynamoDB table at a steady, well-understood rate throughout the year. The company wants predictable billing and the most cost-effective capacity model for the forecast workload. Which configuration should a solutions architect select? Option A. Use on-demand capacity and purchase reserved read and write capacity for the expected traffic. Option B. Use provisioned capacity and configure the required read capacity units and write capacity units. Option C. Use the DynamoDB standard IA table class with provisioned capacity and purchase reserved capacity. Option D. Use on-demand capacity and manually set read capacity units and write capacity units above the forecast peak. The correct answer is B. Use provisioned capacity and configure the required read capacity units and write capacity units. Here's why. Provision capacity lets the company specify the required RCUs and WCUs and pay for that planned throughput. For a constant, predictable workload, it normally provides better cost control than on-demand capacity. Why are the other options not correct? A. Reserve capacity is not available for tables in on-demand capacity mode. C. DynamoDB standard IA tables are not eligible for reserve capacity, so this combination is invalid. D. On-demand mode does not use manually configured RCUs or WCUs and is generally less economical for sustained predictable utilization. Exam tip. Use provisioned capacity for steady, predictable traffic. Reserve capacity is unavailable for on-demand and standard IA tables. Question number 10. A retailer is replacing a self-managed MySQL database on Amazon EC2 with a managed database. The database stores 1 terabyte of data. Its combined read and write workload peaks at 1,000 IOPS, and the new design must support up to 2,000 IOPS. The company also requires automatic failover across availability zones and wants the lowest cost option that meets the performance target. Which solution should a solutions architect choose? Option A. Run MySQL on 2 large EC2 instances in an active-passive configuration. Option B. Deploy Amazon RDS for MySQL in a multi-availability zone configuration with 1 terabyte of general-purpose SSD, GP2 storage. Option C. Deploy Amazon RDS for MySQL in a multi-availability zone configuration with an IO2 provisioned IOPS volume. Option D. Move the transactional database data to Amazon S3 intelligent tiering. The correct answer is B. Deploy Amazon RDS for MySQL in a multi-availability zone configuration with 1 terabyte of general-purpose SSD, GP2 storage. Here's why. A multi-availability zone RDS deployment provides managed high availability and automatic failover. A 1 terabyte GP2 volume supplies 3,000 baseline IOPS, which exceeds the 2,000 IOPS requirement at lower cost than provisioned IOPS storage. Why are the other options not correct? A. A self-managed EC2 design increases database administration and does not provide the requested fully managed failover. C. IO2 can deliver predictable high IOPS, but is unnecessarily expensive for this moderate performance requirement. D. Amazon S3 is object storage and cannot replace a transactional MySQL database. Exam tip. Compare the required IOPS with general-purpose storage performance before paying for provision IOPS. Question number 11. A scientific computing workload runs once each hour and must finish in 15 minutes. Its current execution environment requires 64 vCPUs and 512 gigabytes of memory. The company wants a managed AWS service that can schedule the job and provision sufficient compute with minimal administration. Which solution should a solutions architect recommend? Option A. Run the job as a single Amazon ECS task on AWS Fargate. Option B. Split the job into AWS Lambda functions and use function concurrency. Option C. Run the job through AWS Batch using Amazon EC2 compute environments. Option D. Run the workload on Amazon Lightsail instances with automatic scaling. The correct answer is C. Run the job through AWS Batch using Amazon EC2 compute environments. Here's why. AWS Batch manages queues, job scheduling, and EC2 compute capacity while allowing instance types that can satisfy the 64 virtual CPU and 512 GB resource requirement. Why are the other options not correct? A. A single Fargate task cannot provide the stated CPU and memory combination. B. Lambda cannot supply 512 GB of memory, and the 15-minute maximum duration leaves no execution margin. D. Lightsail is not designed as a managed high-capacity batch scheduling platform. Exam tip. Use AWS Batch with EC2 when a batch job requires resources beyond Lambda or Fargate limits. Question number 12. An archive of engineering documents is stored in S3 standard. Analysis shows that 75% of the objects are rarely read after 30 days. Every object must remain available with millisecond retrieval and continue to be stored redundantly across multiple availability zones. Which lifecycle action will reduce cost while meeting these requirements? Option A. Transition the objects to S3 zone infrequent access after 30 days. Option B. Transition the objects to S3 Glacier Deep Archive after 30 days. Option C. Transition the objects to S3 Standard Infrequent Access after 30 days. Option D. Place the objects in S3 zone infrequent access as soon as they are created. The correct answer is C. Transition the objects to S3 Standard Infrequent Access after 30 days. Here's why. S3 Standard IA provides millisecond access and multi-availability zone resilience, while charging less for objects that are accessed infrequently after the identified 30-day period. Why are the other options not correct? A. S3 zone IA stores data in one availability zone and does not preserve the required resilience. B. S3 Glacier Deep Archive requires a restore process and does not provide immediate access. D. This option both reduces resilience and ignores the observed 30-day frequent access period. Exam tip. Use S3 Standard IA for infrequently accessed data that still needs immediate retrieval and multi-availability zone resilience. Question number 13. A public event portal runs on Windows Server EC2 instances across multiple availability zones behind an application load balancer. The application contains static browser assets and server-side files that every Windows instance must access through a shared file system. Which two actions provide highly available storage and delivery? Choose two. Option A. Place the server-side files on one general-purpose SSD Amazon EBS volume and attach the volume to every Windows instance. Option B. Store the static assets in Amazon S3 and distribute them through Amazon CloudFront. Option C. Place the server-side files on Amazon EFS and mount the NFS file system from all Windows instances. Option D. Store the static assets in Amazon S3 and use Amazon Elastic Cache as the global edge cache. E. Store the server-side files on Amazon FSx for Windows File Server and mount the SMB share from every EC2 instance. The correct answer is B. Store the static assets in Amazon S3 and distribute them through Amazon CloudFront. E. Store the server-side files on Amazon FSx for Windows File Server and mount the SMB share from every EC2 instance. Here's why. Amazon S3 with CloudFront provides durable, highly available global delivery for static assets. Amazon FSx for Windows File Server supplies managed shared SMB storage that the Windows EC2 fleet can mount across availability zones. Why are the other options not correct? A. A standard EBS volume is not a multi-availability zone shared file system for multiple Windows instances. C. Amazon EFS uses NFS and is primarily intended for Linux-compatible clients rather than Windows native SMB access. D. Elastic Cache is an in-memory application cache, not an edge content delivery service for S3 objects. Exam tip. Use S3 with CloudFront for static web assets and FSx for Windows File Server for shared Windows SMB storage. Question number 14. A photo marketplace stores billions of original images in Amazon S3 and serves them through Amazon CloudFront. For each request, the platform must select a suitable image format and generate the requested dimensions based on HTTP request attributes. The company does not want to operate an image processing server fleet. Which solution has the least operational overhead? Option A. Create a CloudFront response headers policy that resizes the image body and changes its format. Option B. Run an image processing library on a dedicated EC2 instance behind the CloudFront distribution. Option C. Associate a Lambda at Edge function that uses an image processing library with the relevant CloudFront behavior. Option D. Create a CloudFront origin request policy that performs the image transformation from the user agent header. The correct answer is C. Associate a Lambda at Edge function that uses an image processing library with the relevant CloudFront behavior. Here's why. Lambda at Edge can execute request-aware transformation logic in the CloudFront workflow and scale without the company provisioning, patching, or managing image processing servers. Why are the other options not correct? A. A response headers policy changes response metadata but cannot modify image content. B. An EC2 processor requires capacity planning, patching, scaling, and high availability management. D. An origin request policy controls which request values CloudFront forwards. It does not execute image resizing code. Exam tip. CloudFront policies modify request or response metadata. Dynamic content transformation requires executable edge compute. Question number 15. A legal services company stores regulated documents in Amazon S3. Bucket access must use TLS, and objects must be encrypted at rest with keys administered by the company's security team. Which solution meets both requirements? Option A. Use an S3 bucket policy with the AWS Secure Transport condition and enable SAA-C03 default encryption managed by Amazon S3. Option B. Associate an AWS Certificate Manager public certificate directly with the S3 bucket and enable SAA-C03. Option C. Use an S3 bucket policy with the AWS Secure Transport condition and rely on Amazon SAA-C to encrypt stored objects. Option D. Use an S3 bucket policy that denies requests when AWS Secure Transport is false and enable SAA-C03 with a customer-managed KMS key controlled by the security team. The correct answer is D. Use an S3 bucket policy that denies requests when AWS Secure Transport is false and enable SAA-C03 with a customer-managed KMS key controlled by the security team. Here's why. The bucket policy enforces HTTPS for data in transit. SAA-C03 with a customer-managed key encrypts objects at rest while allowing the company's security team to administer key policy, rotation, and access. Why are the other options not correct? A. SAA-C03 uses keys managed by Amazon S3, so the security team cannot administer the encryption key. B. ACM certificates are not attached directly to S3 bucket endpoints to enforce client transport security. C. SAA-C discovers and classifies sensitive data but is not an at-rest encryption mechanism. Exam tip. For S3, enforce TLS with AWS Secure Transport and use SAA-C03 when the customer must control the encryption key. Question number 16. Two private Amazon API Gateway REST APIs are used by services in the same VPC. One service currently calls the other through a public API Gateway endpoint, but the company wants the request path to remain private with the fewest application changes. What should a solutions architect configure? Option A. Create a Gateway VPC endpoint for API Gateway. Option B. Create an interface VPC endpoint for the Execute API service. Option C. Require an XAPI key header on the internal request. Option D. Insert an Amazon SQSQ between the two synchronous API calls. The correct answer is B. Create an interface VPC endpoint for the Execute API service. Here's why. Private API Gateway REST APIs are invoked from a VPC through an Execute API interface endpoint powered by a AWS private link. The endpoint keeps traffic on private AWS networking and generally requires only endpoint and DNS configuration changes. Why are the other options not correct? A. Gateway endpoints are available for services such as Amazon S3 and DynamoDB, not API gateway. C. An API key affects request identification or metering, but does not create a private network route. D. SQS would change the synchronous interaction into an asynchronous design and require application changes. Exam tip. Use an interface VPC endpoint to invoke a private API gateway API from AVPC. Question number 17. An Aurora MySQL cluster is encrypted with a customer-managed AWS KMS key. The database owner must provide an encrypted manual snapshot to a partner's AWS account in the same region. Which action should a solutions architect take? Option A. Copy the snapshot with an AWS managed KMS key. Add the partner account to the key alias and share the copy. Option B. Create the snapshot. Grant the partner account permission in the customer managed key policy and share the snapshot with that account. Option C. Download the Aurora snapshot, upload it to an S3 bucket, and grant the partner account access to the object. Option D. Copy the encrypted snapshot to an unencrypted snapshot and share the unencrypted copy. The correct answer is B. Create the snapshot. Grant the partner account permission in the customer managed key policy and share the snapshot with that account. Here's why. Cross-account sharing of an encrypted Aurora snapshot requires a customer managed KMS key that the recipient account is allowed to use. The snapshot itself must also be shared with the recipient account. Why are the other options not correct? A. AWS managed KMS keys and key aliases cannot be modified to provide this cross-account snapshot access. C. Aurora snapshots are service-managed resources and cannot be downloaded as ordinary files for upload to S3. D. An encrypted database snapshot cannot be copied into an unencrypted snapshot. Exam tip. To share an encrypted RDS or Aurora snapshot, share the snapshot and grant the recipient access to its customer-managed KMS key. Question number 18. A company uses a single availability zone Amazon RDS for Microsoft SQL Server DB instance for transaction processing. It needs automatic failover for production. A resource-intensive reporting workload runs only a few times each year and can use a point-in-time copy, but the reports must not slow production transactions. Which two actions should a solutions architect take? Choose two. Option A. Convert the production DB instance to a multi-availability zone deployment. Option B. Use Amazon RDS proxy to postpone report connections until a maintenance window. Option C. Take a current DB snapshot and restore it to a separate RDS DB instance for the reporting run. Option D. Migrate the database to Amazon RDS custom. E. Create a SQL Server RED replica in another availability zone and route every report to it. The correct answer is A. Convert the production DB instance to a multi-availability zone deployment. C. Take a current DB snapshot and restore it to a separate RDS DB instance for the reporting run. Here's why. Multi-availability zone provides managed synchronous standby replication and automatic failover for production. Because reporting is infrequent and can use a copy, restoring a snapshot to a temporary RDS instance isolates the heavy queries from the transactional database. Why are the other options not correct? B. RDS proxy manages and pools connections. It does not offload report processing or schedule queries. D. RDS custom adds administration and does not directly provide the requested combination of managed failover and isolated reporting. E. RDS for SQL Server read replicas requires supported enterprise edition configurations, which the scenario does not establish. Exam tip. Use multi-availability zone for database availability. For occasional heavy reports, restore a snapshot to an isolated reporting instance. Question number 19. A manufacturer is replacing a self-managed MySQL database on EC2. Its disaster recovery plan must maintain a database environment in a second AWS region while minimizing replication, monitoring, and failover administration. Which architecture best meets the requirement? Option A. Copy scheduled database backups to an S3 bucket that uses cross-region replication and rebuild the database after a disaster. Option B. Migrate the database to Amazon Aurora Global Database with the primary cluster in one region and a secondary cluster in the recovery region. Option C. Run MySQL on EC2 in both regions and configure database replication and failover scripts. Option D. Migrate to Amazon RDS multi-availability zone and create read replicas in additional availability zones of the primary region. The correct answer is B. Migrate the database to Amazon Aurora Global Database with the primary cluster in one region and a secondary cluster in the recovery region. Here's why. Aurora Global Database provides managed cross-region replication to a secondary cluster and supports faster regional recovery with substantially less database administration than self-managed replication or restore-based recovery. Why are the other options not correct? A. Replicated backup files provide a restore-based strategy with more recovery work and a longer RTO. C. Operating cross-region, MySQL replication on EC2 requires patching, monitoring, replication management, and custom failover procedures. D. Multi-availability zone deployments and replicas in other availability zones remain within a single region and do not satisfy multi-region disaster recovery. Exam tip. Use Aurora Global Database when managed cross-region replication and a ready secondary database are required. Question number 20. A startup has fewer than 100 users today, but expects rapid growth. It needs a serverless authentication and authorization design for a protected web application that is delivered worldwide. The architecture should minimize login latency and avoid paying for continuously running directory or web infrastructure. Which solution is most cost-effective? Option A. Authenticate users with AWS Directory Service, authorize requests with AWS Lambda, and serve the application through an application load balancer. Option B. Authenticate users with Amazon Cognito, perform authorization with Lambda at Edge, and deliver the application through Amazon CloudFront. Option C. Authenticate users with Amazon Cognito, authorize requests with a regional Lambda function, and use S3 transfer acceleration to deliver the website. Option D. Authenticate users with AWS Directory Service, authorize requests with Lambda at Edge, and host the application on AWS Elastic Beanstalk. The correct answer is B. Authenticate users with Amazon Cognito, perform authorization with Lambda at Edge, and deliver the application through Amazon CloudFront. Here's why. Amazon Cognito provides scalable managed user authentication without directory servers. Lambda at Edge can apply authorization near viewers, and CloudFront delivers content globally on a serverless, pay-for-use model. Why are the other options not correct? A. Directory service and an ALB require provisioned infrastructure, and an ALB does not provide global edge delivery. C. S3 transfer acceleration is intended to accelerate transfers to and from S3, not to serve a global web application like a CDN. D. Directory service and Elastic Beanstalk add managed infrastructure and do not satisfy the serverless, lowest cost objective. Exam tip. For globally delivered protected web content, combine Cognito with CloudFront and Edge authorization logic. Question number 21. A document processing application is being redesigned as a distributed, event-driven system. Individual processing stages should run without servers, and the company needs managed coordination of dependencies, retries, branching, and state with minimal operations. Which solution should a solutions architect select? Option A. Use Amazon EventBridge schedules to invoke independent Lambda functions for every stage. Option B. Define the workflow in AWS step functions, but run each processing stage on long-lived EC2 instances. Option C. Use AWS Glue workflows to coordinate all general application tasks. Option D. Create an AWS step function state machine that invokes AWS Lambda functions for the processing stages. The correct answer is D. Create an AWS step function state machine that invokes AWS Lambda functions for the processing stages. Here's why. Step functions is a managed orchestrator that models state, sequencing, branching, retries, and failures. Lambda provides a serverless execution for each task, so the workflow requires no server fleet. Why are the other options not correct? A. A schedule can trigger functions, but does not model the dependencies and state of a multi-step workflow. B. EC2-based workers do not meet the serverless requirement and add infrastructure management. C. AWS Glue is primarily a data integration and ETL service rather than the general application workflow orchestrator required here. Exam tip. Use step functions to coordinate multi-step serverless workflows and Lambda to execute individual tasks. Question number 22. An online game stores frequently access player state and needs sub-millisecond read latency. Analysts also need occasional SQL queries against historical snapshots without affecting the production workload. The company wants the lowest operational overhead. Which design meets these requirements? Option A. Use DynamoDB for current data. Stream every change through Kinesis data streams and data firehose, and store all records in Amazon S3. Option B. Use Amazon RDS for current data and run a custom periodic export script to Amazon S3. Option C. Use Amazon DynamoDB with DynamoDB Accelerator, DAX, export table data to Amazon S3, and query the exported data with Amazon Athena. Option D. Store all data in Amazon S3, transition old objects to S3 Glacier Deep Archive, and query the archive with Athena. The correct answer is C. Use Amazon DynamoDB with DynamoDB Accelerator, DAX, export table data to Amazon S3, and query the exported data with Amazon Athena. Here's why. DAX supplies microsecond read performance for DynamoDB. DynamoDB export writes a consistent table export to S3 without consuming production read capacity, and Athena supports ad hoc SQL analysis of the exported history. Why are the other options not correct? A. DynamoDB without DAX provides single-digit millisecond rather than sub-millisecond reads, and the streaming pipeline adds services and operations. B. RDS does not meet the sub-millisecond read requirement, and custom export code adds maintenance. D. S3 cannot provide sub-millisecond application reads, and objects in Deep Archive must be restored before they can be queried. Exam tip. Use DAX for microsecond DynamoDB reads, and use S3 exports with Athena for historical analysis. Question number 23. An order platform processes events for many shipments. Events that have the same shipment ID must be consumed in exactly the order in which they are produced, while different shipment IDs can be processed independently. Which two designs preserve ordering for each shipment? Choose two. Option A. Send events to a standard SQ South queue and place the shipment Idaho in a message attribute. Option B. Write events to a Kinesis data stream and use the shipment ID as the partition key. Option C. Store events in a DynamoDB table and use the shipment ID as the partition key. Option D. Send events to an SQS FIFO queue and use the shipment ID as the message group ID. E. Store events in an elastic cache for Memcached cluster under the shipment ID. The correct answer is B. Write events to a Kinesis data stream and use the shipment ID as the partition key. D. Send events to an SQS FIFO queue and use the shipment ID as the message group ID. Here's why. Kinesis preserves record order within a shard, and the same partition key routes a shipment's records to the same shard. SQS FIFO preserves order within each message group, so a shipment ID used as the group ID maintains per shipment sequencing. Why are the other options not correct? A. A standard SQS queue provides only best effort ordering. A message attribute does not add FIFO semantics. C. A DynamoDB partition key groups data, but does not itself provide ordered message delivery to consumers. E. Memcached is an ephemeral cache rather than a durable ordered messaging service. Exam tip. Use a Kinesis partition key or an SQS FIFO message group ID to preserve ordering for each business entity. Question number 24. A fraud detection platform must publish each event to separate scoring, notification, and audit services at the same time. Every subscriber needs its own copy. Duplicate processing should be prevented, and events for a given account must remain ordered. Which messaging service should the company use for fan-out? Option A. Amazon SQS FIFO queues. Option B. Amazon SNS standard topics. Option C. Amazon SNS FIFO topics. Option D, Amazon Event Bridge Event Buses. The correct answer is C, Amazon SNS FIFO topics. Here's why. An SNS FIFO topic provides publish-subscribe fan-out while preserving message group ordering and supporting deduplication. Each downstream service can receive its own ordered copy through an appropriate subscription. Why are the other options not correct? A single SQS FIFO queue distributes messages among consumers instead of sending every event to every service. B. SNS standard topics provide fan-out, but only best effort ordering and at least once delivery. D. Event Bridge routes events broadly, but does not guarantee strict ordering for this workflow. Exam tip. Use SNS FIFO with FIFO subscriptions when multiple services each require an ordered, deduplicated copy of every event. Question number 25. An insurance application sends confidential claim data through Amazon SNS topics and Amazon SQS queues. Both services must encrypt messages at rest with keys limited to approved principals, and their resource policies must reject non-TLS requests. Which two configurations meet the requirements? Choose two. Option A. Encrypt the SNS topic with a customer-managed KMS key and restrict the key policy, but make no change to the topic policy. Option B. Encrypt the SQS queue with a customer-managed KMS key, restrict access only through an IAM policy, and deny requests when AWS Secure Transport is false. Option C. Encrypt the SNS topic with a customer-managed KMS key, restrict key use in the KMS key policy, and configure the topic policy to deny requests when AWS Secure Transport is false. Option D. Encrypt the SQS queue with a customer-managed KMS key and restrict the key policy, but do not enforce TLS in the queue policy. E. Encrypt the SQS queue with a customer-managed KMS key, restrict key use in the KMS key policy, and configure the queue policy to deny requests when AWS Secure Transport is false. The correct answer is C. Encrypt the SNS topic with a customer-managed KMS key, restrict key use in the KMS key policy, and configure the topic policy to deny requests when AWS Secure Transport is false. E. Encrypt the SQS queue with a customer-managed KMS key, restrict key use in the KMS key policy, and configure the queue policy to deny requests when AWS Secure Transport is false. Here's why. The SNS configuration and the SQS configuration both use customer-managed KMS keys, with restrictive key policies for at-rest protection and resource policies that deny insecure transport, thereby enforcing TLS in transit. Why are the other options not correct? A. This protects SNS data at rest, but does not require publishers to use TLS. B. The queue enforces TLS, but relying only on an IAM policy does not establish the required customer-managed KMS key policy control. D. This protects SQS data at rest, but does not reject non-TLS requests. Exam tip. For sensitive SNS and SQS messaging, combine customer-managed KMS encryption with resource policies that deny AWS Secure Transport equals false. Question number 26. An administrator accidentally modifies production data in an Amazon RDS database. The recovery requirement is to restore the database to a point approximately 5 minutes before an unwanted change, as long as the change occurred within the previous 30 days. Which RDS feature should be configured? Option A. Multi-availability zone deployment. Option B. Automated backups with a 30-day retention period. Option C. Manual DB snapshots. Option D. Read replicas. The correct answer is B. Automated backups with a 30-day retention period. Here's why. RDS automated backups retain DB snapshots and transaction logs that support point-in-time recovery within the configured retention window. A 30-day setting allows restoration to a time shortly before the accidental change. Why are the other options not correct? A. Multi-availability zone improves availability but synchronously replicates accidental logical changes to the standby. C. A manual snapshot can restore only to the moment when that snapshot was created. D. Read replicas also receive the unwanted changes and are not a point-in-time backup mechanism. Exam tip. Use our DES automated backups for point-in-time recovery. Use multi-availability zone for availability rather than undoing data changes. Question number 28. A real-time UDP application must continue running on servers in company-owned data centers in North America, Europe, and Asia. Each site already has private connectivity to a nearby AWS region. The company wants lower global latency, better health-based failover, and no migration of the application into AWS. Which architecture should a solutions architect implement? Option A. Create regional application load balancers for the on-premises targets and register the ALBs as AWS Global Accelerator endpoints. Option B. Create regional network load balancers for the on-premises targets and place the NLBs behind an Amazon CloudFront distribution. Option C. Create regional network load balancers with IP targets for the on-premises servers and register the NLBs as endpoints in AWS Global Accelerator. Option D. Create regional application load balancers for the on-premises targets and use the ALBs as origins for Amazon CloudFront. The correct answer is C. Create regional network load balancers with IP targets for the on-premises servers and register the NLBs as endpoints in AWS Global Accelerator. Here's why. Network load balancers support UDP and can forward to reachable IP targets outside the VPC. Global Accelerator accepts the NLBs as regional endpoints, uses the AWS Global Network for the user path, and performs health-based routing while the application remains on premises. Why are the other options not correct? A. Application load balancers do not support UDP listeners. B. CloudFront does not proxy UDP traffic and therefore cannot front this application. D. Both the ALB and CloudFront parts of the design are incompatible with the UDP requirement. Exam tip. Use NLB for UDP endpoints and Global Accelerator for global TCP or UDP performance and fast endpoint failover. Question number 29. A security team wants every IAM user who signs in to the AWS Management Console to follow the same password length, complexity, reuse, and expiration rules. What should a solutions architect configure? Option A. Create one IAM account password policy. Option B. Create a separate password policy for every IAM user. Option C. Use an event bridge rule after each create user event to generate a compliant password. Option D. Install third-party identity software solely to enforce IAM password requirements. The correct answer is A. Create one IAM account password policy. Here's why. An IAM account password policy centrally applies console password requirements, including complexity, reuse prevention, and maximum password age, to IAM users in the account. Why are the other options not correct? B. IAM user password requirements are configured at the account level rather than with individual per-user policies. C. EventBridge does not define or enforce IAM console password complexity and expiration settings. D. IAM already provides the required centralized password policy controls. Exam tip. IAM console password complexity and rotation rules are controlled by a single account-level password policy. Question number 30. A Linux EC2 instance currently runs several independent scheduled tasks that each last about 1 hour. The tasks were built by different teams in different programming languages. The company wants to remove the single instance bottleneck, scale jobs independently, and minimize infrastructure operations. Which solution best meets the requirements? Option A. Rewrite every task as an AWS Lambda function and schedule the functions with Amazon EventBridge. Option B. Package the tasks as jobs in AWS Batch and schedule job submissions with Amazon EventBridge. Option C. Deploy the tasks as an AWS App Runner web service that starts only when a schedule occurs. Option D. Create an AMI of the existing instance and use an auto-scaling group to run full instance copies for each schedule. The correct answer is B. Package the tasks as jobs in AWS Batch and schedule job submissions with Amazon EventBridge. Here's why. AWS Batch queues and scales containerized jobs on managed compute environments, while EventBridge schedules job submission. Each language can be packaged independently, and no permanent worker instance is required. Why are the other options not correct? A. Lambda functions have a maximum execution duration of 15 minutes, so they cannot run 1-hour tasks without major redesign. C. App Runner is intended for continuously running web applications and AP is rather than scheduled batch jobs. D. Replicating complete instances adds capacity management overhead and does not isolate or scale the individual tasks efficiently. Exam tip. Use AWS Batch with EventBridge for scheduled, scalable, long-running jobs implemented in different languages. Question number 31. A digital publishing platform runs application servers in private subnets across several availability zones. The servers must periodically contact a third-party licensing endpoint on the public internet. The company wants managed outbound IP version 4 connectivity with minimal administration. Which solution meets these requirements? Option A. Deploy a private NAT gateway in a private subnet and direct each private subnet's default route to the gateway. Option B. Deploy a public NAT gateway in a public subnet and direct each private subnet's default route to the gateway. Option C. Deploy a NAT instance in a public subnet and configure the private subnet route tables to use the instance. Option D. Deploy a NAT instance in a private subnet and configure the private subnet route tables to use the instance. The correct answer is B. Deploy a public NAT gateway in a public subnet and direct each private subnet's default route to the gateway. Here's why. A public NAT gateway is a managed service that allows instances in private subnets to initiate IP version 4 connections to internet destinations. Routing 0.0.0.0/0 from the private subnets to the gateway provides the required path without maintaining a NAT server. Why are the other options not correct? A. A private NAT gateway is intended for private network connectivity and cannot use an internet gateway for public internet access. C. A NAT instance can provide outbound connectivity but requires patching, scaling, monitoring, and failover administration. D. A NAT instance in a private subnet does not have the public routing required to reach the internet. Exam tip. Use a public NAT gateway for managed outbound IP version 4 internet access from private subnets. Question number 33. An emergency response organization maintains millions of high-resolution satellite images. Each image is associated with one parcel identifier. During a major incident, tens of thousands of images can be replaced within a few minutes. The architecture must scale automatically, remain highly available, and minimize cost. Which solution should a solutions architect recommend? Option A. Store the parcel identifiers and image binaries in an Oracle database running on an Amazon RDS multi-availability zone deployment. Option B. Store the parcel identifiers and image binaries as DynamoDB items and add DynamoDB accelerator during traffic spikes. Option C. Store the images in Amazon S3 and maintain the parcel-to-object mapping in an Oracle database on Amazon RDS multi-availability zone. Option D. Store the images in Amazon S3 and use Amazon DynamoDB to map each parcel identifier to the corresponding S3 object location. The correct answer is D. Store the images in Amazon S3 and use Amazon DynamoDB to map each parcel identifier to the corresponding S3 object location. Here's why. Amazon S3 provides durable, economical storage for large image objects. DynamoDB provides highly available key-value lookups and automatically scales the parcel-to-object mappings during sudden update bursts. Why are the other options not correct? A. Placing large image binaries in Oracle increases database storage cost and limits elastic scaling. B. DynamoDB items have a maximum item size, and DAX primarily accelerates reads rather than solving large object storage and write scaling requirements. C. S3 is suitable for the images, but an Oracle multi-availability zone database is more expensive and less elastic than DynamoDB for a simple identifier mapping. Exam tip. Store large binary objects in SAA-C03 and place scalable metadata or object references in DynamoDB. Question number 34. A transportation company continuously delivers vehicle telemetry to Amazon S3 by using Amazon Data Firehose. The process creates trillions of objects. Data from the most recent 30 days is read every day. Data between 30 days and 1 year old is read quarterly, and data older than 1 year is retained only for compliance archives. Which storage design is most cost-effective? Option A. Store new objects in S3 standard, transition them to S3 standard IA after 30 days, and transition them to S3 Glacier Deep Archive after 1 year. Option B. Store all objects in S3 standard IA from creation and transition them to S3 Glacier Deep Archive after 1 year. Option C. Store the objects in S3 intelligent tiering and enable automatic movement to the Deep Archive Access tier after 1 year. Option D. Store the objects in S3 intelligent tiering and use an S3 lifecycle rule to move them to S3 Glacier Deep Archive after 1 year. The correct answer is A. Store new objects in S3 standard, transition them to S3 standard IA after 30 days, and transition them to S3 Glacier Deep Archive after 1 year. Here's why. The access pattern has 3 predictable phases. S3 standard supports frequent initial access. S3 standard IA reduces storage cost for quarterly access while retaining immediate retrieval, and Deep Archive minimizes long-term archival cost. Why are the other options not correct? B. S3 standard IA is not cost-effective for objects that are read every day during their first 30 days. C. Intelligent tiering monitoring across trillions of objects adds per-object charges, and automatic archival behavior does not match the explicitly known lifecycle as directly. D. Intelligent tiering adds monitoring charges even though the company already knows exactly when each access phase changes. Exam tip. When data access phases are predictable, use explicit S3 lifecycle transitions rather than paying to monitor changing access patterns. Question number 35. A manufacturer operates applications in 3 VPCs in one AWS region. The VPCs must communicate with one another and exchange hundreds of gigabytes of latency-sensitive data each day with a single on-premises facility. The company wants consistent network performance without purchasing redundant dedicated connections. Which architecture is most cost-effective? Option A. Establish one AWS site-to-site VPN connection from the facility to each VPC. Option B. Purchase a separate AWS Direct Connect connection for each VPC and associate the connections with a Direct Connect gateway. Option C. Establish one AWS Direct Connect connection, attach the VPCs to an AWS Transit Gateway, and connect the Direct Connect gateway to the Transit Gateway. Option D. Deploy a third-party VPN appliance in every VPC and create an IPsec tunnel from each appliance to the facility. The correct answer is C. Establish one AWS Direct Connect connection, attach the VPCs to an AWS Transit Gateway, and connect the Direct Connect gateway to the Transit Gateway. Here's why. Direct Connect provides predictable high-bandwidth hybrid connectivity for the latency-sensitive transfer. Transit Gateway supplies a central routing hub for the 3 VPCs and allows them to share the dedicated connection. Why are the other options not correct? A. Site-to-site VPN uses the public internet and generally provides less consistent latency than Direct Connect. B. A separate Direct Connect circuit for every VPC adds unnecessary recurring cost. D. Multiple self-managed VPN appliances and tunnels increase licensing, maintenance, and availability responsibilities. Exam tip. Combine Direct Connect, a Direct Connect gateway, and Transit Gateway when several VPCs need to share dedicated hybrid connectivity. You have completed part 1 of the SAA-C03 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.